In this problem, we have two gears that are adjusted so that the smaller gear, the one in blue, drives the larger one, the one in pink. So the smaller gear has a radius of 3.5 centimeters and the larger gear has a radius of 6.9 centimeters. So if the smaller gear rotates through an angle of 270 degrees, so the angle that this small gear is going to rotate is 270 degrees. The question is asking us through how many degrees will the larger gear, this one, rotate. So what is the angle that the larger gear is going to rotate? So to solve this problem, we need to use the arc length formula. So the arc length formula is something that goes by S equals R theta. S refers to the arc length, R refers to the radius, and theta refers to the angle of the arc. So R we have for the one in blue and the one in pink. Theta we sort of have, but it's not in the right form. So first what we have to do is we have to convert 270 degrees into radians. So 270 degrees equals what in radians? Well, if I start with what I know, which is 180 degrees is equal to pi radians, I can figure out what 270 degrees is by thinking, okay, what do I have to multiply 180 by to get 270? Well, if I multiply 180 by 270 over 180, 180 cancel out, and I just get 270. So since I multiplied this left side by 270 over 180, I'm also going to multiply the right side, pi, by 270 over 180. Now 270 over 180, I can cancel the zeros, so I would have 27 over 18, but 27 over 18 can further be simplified. I can divide both by 9. 27 divided by 9 gives me 3. 18 divided by 9 gives me 2. So I get 270 over 180 simplified to 3 over 2 pi. So 270 degrees is equal to 3 over 2 pi. So that's good. Now we can finally use not 270 degrees, but 3 pi over 2 into the arc length formula. So how are we going to use this arc length formula? Well, if you think about it, if this small gear rotates a certain number of degrees, the distance that it's going to go is going to be the same as the bigger gear, but the only difference is the angle that it's going to rotate through is smaller. So again, the distance is going to be the same for both of them. So what I can do is say, okay, so here is going to be the arc length formula for the small gear. It's going to be S, which I don't know. So actually, let me use the blue one so we know. The blue one, blue marker for the small gear, S equals R theta. R is going to be the radius, which is 3.5 centimeters, times theta, which we're not going to use 270. We're going to use the angle and radians, so 3 over 2 pi. So 3 over 2 pi. So this is the arc length formula applied with the smaller gear. Now we can do the same for the bigger gear, so I'll use the same color marker, which is going to represent the big one. So S is going to be equal to the radius 6.9 times theta. Now again, the angle is going to be different. It's going to be less than 270, but we don't know what it is, so I'm just going to write theta. The angles are different, but like I said before, the distance is the same. Set them equal to each other. So I'll write 3.5. I'll write that as a fraction, which I know is 35 over 10, and then times 3 over 2 pi. I'll set that equal to this one, the arc length formula for the bigger gear. So instead of writing 6.9, I'll write its fraction form, 69 over 10 times theta, which again we don't know, so I'm just going to write theta. Now we want to solve for theta, so I'm going to multiply both sides by the reciprocal of this fraction. So 10 over 69, 10 over 69. And by doing that, 10 and 10 cancel out, 69 and 69 cancel out. I'm going to have theta equals 10 and 10 cancel out, 35 over 69, and 3 over 2. If I do the multiplication, well, I can simplify 69 and 3. 69 and 3, I can divide both by 3, so I'll just change 69 to 23, and I'll change 3 divided by 3 to 1, and then so the numerator is going to be 35 times 1, so I would just get 35 over 25, 10 is gone, and I just have 2, so 23 times 2 gives me 46. And don't forget the pi, radians. So theta is going to be equal to 35 over 46 pi radians. But the question is asking us for the answer in degrees, so we got to convert this to degrees. So 35 over 46. Pi, again, is equal to 180 degrees, so I'll just replace pi with that number, 180 degrees. And if you plug that into a calculator, if you do 35 divided by 46 times 180, you would get an answer of 136.9565 and numbers after that. But we don't need to write the whole number because it's saying to round to nearest integer as needed, so the integer would be 136, but we look to the number to the right of that, the 9. The 9 is bigger than the 5, so the 6 rounds up 1, so it would actually be 137 degrees. So the large gear will rotate approximately 137 degrees. So again, to solve this problem, you are going to have to use the arc length formula, S equals R theta. You're going to have to make one version for the smaller gear, which we did, S equals 3.5, that's R for the small gear. You multiply it by the radian angle, which is 270. We changed that to 3 over 2 pi. We did the same thing for the bigger gear. We used S equals R theta again, so S equals 6.9, so we wrote 6.9. We didn't know what theta was, that's what we solved for, so we wrote theta. We set them equal to each other, and we solved for theta and got 137 degrees. So the answer again is 137 degrees.